Okay, on 31 through 40, we were supposed to factor. So, when we get to the point where it's a leading coefficient from 1, I'm going to make sure that you know. I'm going to show you a couple different ways, okay? Because depending on who your teacher was or what you remember, you might decide to do it a different way. Okay, so just the basics. I'm trying to factor n squared minus 10n plus 25. I need the factors of 25 that add up to negative 10. So I need the factors of 25 that add up to negative 10. Now you might do this different ways. You might do it with an x or whatever. Okay, I don't know what you do. But we need the factors of this that add up to that, however you write it. So 1 and 25, 5 and 5. And if I think about 5 and 5, they add up to positive 10, but if they're both negative, they multiply to give me positive, but add to give me a negative, so it'll be n minus 5 and n minus 5. And that is my answer. If I were to distribute that back out, n squared minus 5n is minus 10n, and then negative 5 times negative 5 is 25, so it works out. If you're factoring, and you need it on a test, in the process of solving something else, check it right quick. It's worth your time. Okay, we need the factors of the constant that add up to the middle term, or the middle coefficient, not the leading coefficient. So I need the factors of negative 30 that add up to positive 1. And if you know them, you can just jump straight to them. If not, you got to write them out. 130, 215, 3 and 10, 5 and 6. 5 and 6 have a difference of 1. I need a negative 30, which means one of them needs to be negative, and the 5 is it because I need a positive one I'm going to add. So n minus 5 and n plus 6. Okay. On this one, you might notice this is n cubed, but they all have an n, which means this technically has a common factor of n. So I'm just going to put an n out to the front and then treat it as if this was squared 1 and none. Okay. So I need the factors of negative 20 that add up to negative 8. 1 and 20, 2 and 10. 2 and 10 have a difference of 8. I need a negative 8 when I add and a negative when I multiply, so 1 is negative and it is the 10. So n plus 2, n minus 10. Okay. This one has 4k squared minus 4k minus 224. And you might think, okay, different leading coefficient of 1 or not 1, so I need to do the AC method or group factor by grouping or bottoms up. But, in fact, I see a 4, and a 224. For sure 224 divides by 4, because 200 does, and so does 24. So I'm going to divide it out, which means it's a common factor. 4 divided by 4 is 1. 4 divided by 4 is 1. 224 divided by 4 is, if you're unsure, you don't have a calculator, 4 goes into 2 no times, 4 goes into 25 times. Subtract, bring down the 2, bring down the 4, 4 goes into 24 6 times, so 56. Okay? So, in effect, what we're doing now is we're factoring k squared minus k minus 56 with a common factor of negative or positive 4 on the front. So what are the factors of negative 56 that add up to negative 1? And you might know that 7 and 8 have a difference of 1. If I need a negative 1, then that means a larger number needs to be negative. So I'm thinking k plus 7 and k minus 8. Okay, on number 35. There's only 2 terms, so let's see what we end up with after we factor out common factors. They both divide by 2, and they both have at least 2 n's in them. This one has 4, that one has 2. So I've got 2n squared, and I'm left with 2 n's there. 19 divided by 2 is not, or 18 divided by 2 is 9, and the n squared is gone. Okay, so I've got 2n squared times n squared minus 9. And if you quit there, I mean, you would only get half the credit as far as if the goal was to factor, you did half of the work, because you got to recognize that this right here is the difference of perfect squares. Okay, and if you think of it as n squared plus 0n minus 9, what are the factors of negative 9 that add up to 0? It's positive 3 and negative 3. Okay, so or you can just remember this is a perfect square, that's a perfect square. The factors of, or the square root of 9 is 3, so n plus 3, n minus 3. Anytime it's a difference of perfect squares, you can just do the plus and minus. Okay? 35r squared plus 205r plus 150. And Okay. I can definitely tell that there's a factor of 5. So let's go ahead and see what happens there. I'm left with 7r squared. It goes into it 504 times, so 41. So 30? Yeah? Okay. Yeah, and nothing else goes out of that, because 7 isn't going to 41 or 30. So, I need the factors. Okay, so now I need to do factor by grouping or bottoms up. So let's do both of those. Okay, I'm going to kind of forget about the 5. I mean, the 5 is going to be part of my answer, but it's not going to be part of my methodology. I don't need to worry about it right now, because I've taken care of it. It's in front of my answer. If you do factor by grouping, then you would do this. 7 times 30. 7 times 30 is 210. And then you would try to find the factors of 210 to add up to 41. Yeah? So 210 is 1 and 210. 2 and 105. Let's see, 3 goes into it 70 times, yeah? It's 40. 4 goes into... Nope. 5 goes into it, let's see, 42 times, right? Yes. Yes. What's 42? 42 is 6 times 7, right? So I've got 5 times 6 times 7. Let's see, so that is 30 times 7. Okay. 5 times 2 times 3 times 7. That is 10 times 21. That doesn't go to 41. Did I do 41 right? Or is it 31? No, that's 41. No? No? No, okay. Let's see, 15 and 14? That doesn't add up to... What am I missing? 30, oh, geez Louise. Are you kidding me? 35 and 6. 5 times 7. Next daggum one. Okay. 6 and 35. Good Lord. 6 plus 35 is 41, and so there's my factors. Okay. If you do factor by grouping, you have a couple different options you can rewrite. You use the 6 and the 35 to rewrite 41. You can either do 7r squared plus 6r plus 35r plus 30, or 7r squared plus 35r plus 6r plus 30. So you might notice that all I did was, in both cases, I rewrote 41r as just 35 plus 6. And you didn't change the equation. I haven't changed the equation. It depends on how you choose to write it. If you choose to write it the first way, then when you group, you think, what can I factor out of both of these? And the only thing I can factor out is 7r squared and 6r is an r. I'm left with 7r plus 6. One of the r goes away and that r goes away. If I think about 35 and 30, the only thing I can factor out is a 5. So I'm left with 5 goes into 35 7 times. 5 goes into 36. So I get 7r plus 6. So what you do is you factor that out, that quantity, 7r plus 6, and you're left with r plus 5. Because remember, if this had been right here, if you'd had r times a star plus 5 times a star, and you factored out the star, you'd be left with r plus 5. Well, that star happens to be the quantity of 7r plus 6. So even though it's two quantities, you can still factor it out into one. Okay? If you had done it with the 35 first, because you were thinking 7 and 35, then you would do this. The factors that go into both are 7 and an r, and I'm left with 1 r, and 5, because the r goes away. 6 goes into both, so I'm left with r and 5. So I'm left with r plus 5 and 7r plus 6. Okay? final answer, 5 times r plus 5 times 7r plus 6. But there's a little bit easier method. And I don't know if you learned it or not. If you haven't, I want you to learn it now because it makes it a whole lot faster, especially when we're solving. But if you have, then good. So if you've got 7r squared plus 41r plus 30. Now, the method that I'm going to show you, if you didn't already factor out that 5 in the front, it would disappear, and that would mean your answer isn't valid. So you got to be careful about that. So what you do is you factor it like normal. 7 times 30 is 210. You need the factors of 210 to add up to 41, and it's 6 and 35. So you just pretend like that 7 wasn't there and that was just a 210. That would be your answer, right? But we in fact did multiply by that 7, so you divide by the 7, the number that you multiplied by. If it doesn't simplify, then you move it up to the front, so it's called bottoms up. So 7r plus 6, 35 divided by 7 is 5, and 7r plus 6, r plus 5, and 5. Okay. We will talk more about that later, okay? Because there's definitely some things you gotta know about it. So that one is 5, 7r plus 6, r plus 5. Okay, on number 37, I need to first take out the common factor of x. So I've got an x out the front. I've got 7x squared plus 11x plus 4. I don't know why I did that, rewriting it, but whatever. So the final answer is going to have an x out the front. And then it's a leading coefficient different from 1, so I'm going to go ahead and do bottoms up. 7 times 4 is 28. So I need the factors of 28 to add up to 11, and they are 4 and 7. So normally I would put x plus 4 and x plus 7 and call it good, but because we multiply by that 7, you got to remember to divide by that 7. That does not simplify, so bottoms up, 7x plus 4. That does simplify down to 1, so it's just x plus 1. And there you go. Okay. On 38, there's a 2 in the front, but that's 17, so it's not a common factor, so I don't have to worry about common factors. So I need the factors of, so it's 2 times 36, which is 72. That adds up to negative 17. I'm going to not miss this up again. 8 and 9. Yeah, 8 and 9. 8 times 9 adds up to 17, and they multiply to give me 72. And so I need a negative 17, which means they both need to be negative. Okay? So I've got v minus 8 and v minus 9, but don't forget to divide by the number you multiplied by. So I need to divide both sides, or both of these by 2. This simplifies down to a 4, so that's v minus 4. This does not simplify, so 2v minus 9. And remember, you can always test it. 2v squared, check. Minus 9v minus 8v minus 17v squared. Check, not squared. Negative 4 times negative 9 is positive 36, so we're good. Okay. On 39, I've got 3, 10, and 7, so no coefficient is a common factor, but I have at least p squared in each, so I've got a p squared out in the front of my answer. I'll just get rid of those. And then I need the factors of 21 that add up to 10, and they are 3 and 7. So think about it as p plus 3, p plus 7, and I need to divide by the number I multiplied by, so 3. That simplifies down to 1, so p plus 1, and p plus 7 thirds, so the 3 goes at the front. Do I care about which one is first? I do not. Multiplication is associative. Or commutative. Commutative. Okay. Here, I've got 5 and negative 1, negative 6, no common factors, k squared, k, no k. Okay, so 5 times negative 6 is negative 30. I need the factors of negative 30 that add up to negative 1. There are 5 and negative 6. So think of it as k plus 5, k minus 6. I need to divide by 5, which is what I multiplied by. So final answer, k plus 1 and 5k minus 6. Bottoms up. Okay? Factoring is not one of those things you can get away with not knowing. You have to know it, okay? If you don't know it, we will at some point probably be giving quizzes on factoring just randomly or for a long time to make sure that everyone gets them. Okay, sketching the graphs of quadratics. So, I don't know if you remember vertex form, but the vertex form of a parabola, you've got y equals a times x plus h, or x minus h, quantity squared plus k, where the vertex is the point hk. Notice how that's a negative. It's the opposite of what the x value is, and then the plus k. I don't know if you remember transformations, but transformations would say, if I have this, on the inside you go the opposite. So if it says minus h, I'm going to go to the right h, and then up k on the outside. So on the inside with the x, you're changing x, which is a left and right shift, and the outside you're changing the y, because you've already affected the x, you're changing the y value up and down, and that's exactly what it looks like. Plus is up, minus is down. And then the A is a vertical stretch or compression, and we'll talk more about that when we talk about radical functions and transformations, but as is, I'll show you how to kind of use that. Okay? So what I know is that x minus 1 squared plus 4, and it does say no calculator. I want you doing this without a calculator. I want you thinking about vertex form and using what you know, and then just not typing it in, filling it in your head. So I know that I'm going to go to the right one and up 4, and that's going to be my vertex. To the right one and up 4, and there's my vertex. Now, in order to graph a parabola on this assignment, if the 5 points are available, then you have to graph at least 5 points, the vertex, and then 2 on each side. The next one, you could just go ahead and plug in 2. If I plug in 2, 2 minus 1 is 1, 1 squared is 1, and 1 plus 4 is 5. So I actually know that it's at 5. Or you can use the number in the front, and here's what I know. If I go to the right one and to the left one of the vertex in a parabola, it's always going to be, you go up or down that number in front. So if it says plus 1, then I go to the right one and go up 1, left 1 and up 1. But I could have said 2 minus 1 squared plus 4. That's 1. 1 squared is 1. 1 plus 4 is 5. Okay? So I could have done that. And if you know this one, then you can mirror it over there because they're symmetrical. Now, you can't do that, the slope thing, it's not slope, but you can't do that vertical stretch or compression thing with the next one because it's a quadratic, it's a curve, it doesn't change at the same rate. Otherwise, it would be linear, or an absolute value in this case. So I have to substitute in 3. So 3 minus 1 squared plus 4. 3 minus 1, and if you go 2 points over, which is what we're always going to be doing, it's always going to be something minus 2 less than itself. That's going to be 2. 2 squared is always 4, and 4 plus 4 is 8. So I know that 3, I'm at 8. And if I'm at 8 this way, then I'm at 8 over here as well. And then let me do this. Now I don't have it on there, but I'm probably going to add it on your assignment, just talking to you. I want you to tell me domain and range and the vertex. Okay, so the vertex we just added was at the positive 1 and the positive 4. Domain is left and right, so does it go all the way left and all the way to the right? Look, it's just going left, it's going to the right. All real numbers. Range is high and low. The lowest it goes, you always have to go from low to high. The lowest it goes on the y-axis is 4, which we include because you reach all the way down to 4. And then it goes all the way up to positive infinity. It's got those arrows, so 4 to infinity. We don't put a bracket on infinity because you can't include infinity. You don't technically ever reach it. Okay. On 42. If you look at 42, we got a negative in the front. Let's make that a negative 1. So I understood 1 there. But if I'm trying to find the vertex, then I remember it's the opposite on the inside. So if I go minus 3, then it means to the right 3. And then plus 3 means go up 3. So 1, 2, 3, and then 3. So go 3 and up 3. Make sure you make note of the scale. And there we go. So I could plug in 4, and I'm always going to go to the right one. I could plug in 4, a negative 4 minus 3 squared plus 3 if I want to figure out what the y value is. Or I can just know that if I go to the right one and to the left one, this is how much I go up or down. And it's negative 1, so I'm going to go to the right one and go down 1. And left one and go down 1. And sure enough, I will get 2 if I do this. 4 minus 3 is 1, 1 squared is 1, negative 1 plus 3 is 2. Okay? Now I want to plug in one more point over, so I'm going to plug in a 5. So 5 minus 3 squared plus 3, and like I said, it's always going to be 2. 2 squared is 4, negative 4 plus 3 is negative 1. But I don't want to see your V's on these, so try and make it a curve, okay? And you have to draw the arrows at the end, so that I know that you know it keeps on going. Okay, we got vertex, we need domain and range. Domain is left and right. So does it go all the way left and all the way to the right? Yes, it's just going to keep on going. So all real numbers. Range, you got to go low to high. The lowest it goes is down here to negative infinity. And the highest it goes on the y-axis is 3. And we reach it, so we put a bracket. Okay, on 43, it says plus 3 on the inside, which means that my vertex is to the left 3, which kind of should give you a clue with the graph being over here. So left 3 and up 4, because it's positive. Left 3 up 4. Now, as far as the next point, I'm going to go to the right and left 1. So if I go to the right one and left 1, I go this number. So if I go to the right one, that means I'm going to go down 3. 1, 2, 3. And left 1 down 3. And if you think about this, looking at this, this is going to be kind of a skinnier parabola, which makes sense, because this has been that was a 1 and that was a negative 1. The only difference between the shapes were one was up and one was down, but they were the same shape. This is a little bit more zoomed in, so it looks wider a little bit, but it's not. But this is definitely going to be skinnier because of the 3 in the front. I don't know if you remember, but that's called a vertical stretch by a factor of 3. So if you take something and then you stretch it vertically, then it is going to make it skinnier. It's going to change it at a faster rate. Okay? We need one more point. So I always go to the right, another one, so that's when x equals negative 1. So you could just do this in your head, like when x equals negative 1. Negative 1 plus 3 is 2. 2 squared is 4, like I said. 4 times negative 3 is negative 12, and negative 12 plus 4 is negative 8. Or you can just write it out. Negative 3 when x equals negative 1. You could do when x equals negative 5, but you just got to remember if you have negative 5 plus 3, it's a negative 2, but negative 2 squared is still a positive. I'll just avoid that in case you're prone to making that mistake. But a negative 2 squared is the same thing as a positive 2 squared. So negative times itself is a positive. Okay? Okay. So negative 1 plus 3 is 2. 2 squared is 4. That's a negative 12. Negative 12 plus 4 is a negative 8. So at negative 1, I'm at negative 8, which means at negative 5, I'm at negative 8. Connect. Okay. Domain is left and right. It goes all the way left and all the way to the right. All real numbers. You might be asking yourself, are all the domains on quadratics all real numbers? And I would say yes. Okay. Range is low to high. The lowest it goes is negative infinity. And the highest it goes is up to positive 4. And then it stops. Okay. This has a 2 in the front, so I know it's going to be a vertical stretch by a factor of 2. If it had been a 1/2 in the front, I would have said vertical compression. Okay, so I'm going to go, it says a negative 3, so I'm going to go to the right 3 on the inside, but then it says negative 3 on the outside, so I'm going to go down 3. So my vertex is at the point positive 3, negative 3. And then if I go to the right 1 and left 1, I know that I'm going to go up 2 because it's positive. Okay? And then I need to find the next point, so I'm going to go to the right one more time. 5. 5 minus 3 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. So I'm at 5, or I could say when x equals 5, what does y equal? So 5 minus 3 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5. So at 5, I'm at the point 5, which means at 1, I'm at 5. So connect. Trying to do a better job than I'm doing. Yes. Okay. Domain and range. Domain is left and right. It goes all the way left, all the way to the right. So our real numbers range low to high. The lowest it goes is only -3, and the highest it goes is up to positive infinity. Okay? If you say positive infinity -3, I will not give you full credit. Okay? Alright. Now on 45, we're supposed to sketch, but it's not in vertex form. We could learn a method to put it in vertex form, but we're going to go ahead and just plug in numbers. So let us see. The easiest one to plug in is 0. Because if you plug in x equals 0, you get 0 squared times 2 minus 8 times 0, which is 0 plus 6. It's just 6. So I'm going to go 0 and 6. I'm going to plug in 1. So I've got 1 squared is 1, times 2 is 2, minus 8 times 1, which is minus 8 plus 6. So 2 times a negative, 2 times. 2 minus 8 is -6, plus 6 is 0. So at 1, we're at 0. And if your numbers start getting crazy, if you can't see them, then go the other direction. So I'm going to plug in 2. So I've got 2 squared, which is 4. 4 times 2 is 8. 8 times 2 is 16, so minus 16 plus 6. 8 plus 6 is 14, and 14 minus 16 is a -2. So I'm at -2. Let's go with 3. 3 squared is 9. 9 times 2 is 18. 3 times 8 is 24, so minus 24 plus 6. 18 plus 6 is 24, and 24 minus 24 is 0. So I guess I did have a 0 there, equals. So I'm back at 0. Now, it's a pretty good bet, since we're talking about a quadratic, that if I went 6, 0, -2, and then back to 0, that the next one is going to be positive 6. I can check it though, which means that's the vertex. 4 squared is 16. 16 times 2 is 32. 4 times 8 is 32. And then plus 6, so that is 6. Okay, we found the vertex and we found it. So we're going to sketch. Without a calculator. Okay. My vertex looks like is the point 2, -2. Domain is all real numbers, and range, the lowest it goes is -2, and the highest it goes is infinity. Okay. Let's do the same thing with this one. Now, the fact that this had a positive 2 in the front led me to believe that since this was 2 and that was the next one over was 0, that it was the vertex. You might notice that this is a -1 in the front, so you know it is going to face down, and then it's a matter of figuring out what to do. So let's go ahead and do that. Okay, the last problem I started with 0, because I was like, oh, that's easy. I'm plugging 0 here and 0 there, they're gone, but I got -19. Which means the 0 is down here at -19, which I'm not going to graph. Just can't see it. So I'm going to go ahead and plug in 1. Let's see. We'll plug in 1, then I've got 1 squared. Remember, this is a -1 squared. It's not -1 squared. That negative is not inside the square. If it was, it wouldn't even be there. So that's a -1. And then 1 times 8 is 8 minus 19. -1 and -19 is -20, and -20 plus 8 is a -12, which I still can't see. So we'll try 2. Okay. 2 squared is 4, so that's a -4. 2 times 8 is 16, and then minus 19. So I've got -4, -19, that is a -23, plus 16, that is a -7. Yeah, that was a 2. Okay, let's try 3. I've got a -3 squared, which is -9. 3 times 8 is 24, minus 19. -9 and -19. Well, let's just go ahead and, no, just do 24 minus 19 is 5. And then 5 and -9 is -4. So at 3 I'm at -4. Let's go with 4. 4 squared is 16, so -16 plus 32. 4 times 8 minus 19. Okay, 32 minus 16 I know is 16, and 16 minus 19 is -3. Okay, I have enough to go ahead and sketch the rest, because here's what I know. I know it's a downward facing parabola, and I know that this is a -1 in the front, which means when I find my vertex, if I go to the left and the right one, I would go down 1. So since that's the left one and down 1, I'm thinking that's going to be the right one, down 1. And that's going to end up right there. I could check. Just plug in 6. I've got a -6 squared, which is a -36. 6 times 8 is 48. And then minus 19. 48 minus 36 is 12. And 12 minus 19 is -7. So we're good. Okay. Domain and range. And vertex. Vertex looks at the point 4, -3. Domain is all our numbers. It goes all the way left and all the way to the right. Range, the lowest it goes is down to -infinity. And the highest it goes is -3. Okay? Alright, solve each equation with the quadratic formula. So first, before you know it, you gotta know the quadratic formula. So if you don't remember the quadratic formula, it's something that you should do your best to remember. If you're trying to solve ax squared plus bx plus c equals 0, then you can do x equals the opposite of b, so the opposite sign, plus or minus the square root of b squared, the middle coefficient squared, minus 4 times the leading coefficient times the constant ac, all over 2 times the leading coefficient. Okay? So if I'm filling in this one, my numbers in the front are 1, my coefficients are 1, -4, and -16. Okay, so let's fill it in. X equals opposite b, and then it might be kind of confusing with b's, but opposite b is the opposite of this middle coefficient, so positive 4, plus or minus the square root of b squared, which is the middle coefficient squared. Now, you can write -4 squared. What you can't do is write that. Now, maybe you will know it, but I don't like that. You either need to put parentheses, or you just don't need to write that at all and just write 16. Because a -4 squared is a -4 times a -4, which is positive 16. But it is the worst when you miss this, or a problem that requires somewhere in it you saw in the quadratic formula, but you put that a negative right there. No. A negative squared is always positive. So if you just want to write 16, that's perfectly fine with me. Minus 4 times a, which is 1. Do you need to write down 1? No. Okay. Times c, which is -16. Don't forget the negative. All over 2 times a, which is 1. So, in effect, here's what we have. 4 plus and minus the square root of 16, and then -4 times 1 times -16. -4 times a -16 is a positive 4 times 16. And I'm just saying, you could think of it as 16 plus 4 16s is 5 16s. 5 16s is 80. Or you can say 16 plus 4 times 16 is 24, so yeah, no, just kidding. Yeah, 4 times 6 is 24, 64. And that makes sense. 64 all over 2, 16 plus 64 is 80. Duh, that's what I said. 4 plus and minus the square root of 80 all over 2. But you have to remember that you have to divide it by or you have to simplify the expression inside the square root. So square root of 80. So when I think about what goes into 80, you got to remember the perfect squares. So 4 goes into it, yes, 20 times. But 20 is also divided by 4, which leads me to believe that 16 divides out of it. And how many times? And 5 times, because that's 4 times 16 plus 1 times 16 is 5 times 16. So this is actually 4 plus and minus 16 times 5, the square root, 16 times 5 over 2. Okay? You know what you can't do is divide this 4 by 2 yet. Okay? Do not do that. You can't divide that 80 by 2 at all because 80 is inside the square root and 2 is not. Do not simplify those until you know whether or not you can simplify with the numerator. Okay? Not with the numerator, with the second term. The square root of 16 is 4. So 4 plus and minus 4 square roots of 5 over 2. Okay? And then because these both divide by 2, then I can say this divided by 2 and this divided by 2. What you can do is think of it like this. You factor a 2 out, and then these two simplify out. You can only simplify with multiplication, but by doing this, then you're dividing everything by 2, that's okay. But you can only do that if you divide that. I have a lot of people that would say right here, here's my answer, and then simplify the square root of 80, and that's wrong. You cannot do that unless you can also do it in front. Or you can, but you got to remember that this is also divided by 2, not just that. Okay? So, the final answer should be 2 plus or minus 2 square roots of 5. We will do more practice work on the quadratic formula, but it's definitely something you're going to have to work at. Okay. On 48, we've got, and I said x on the last one. The variable should have been b. Oh well. So n equals opposite b, so positive 5, plus and minus the square root of b squared, so negative 5 squared. I'm just going to go and write 25, minus 4 times a, which is 2, times c, which is negative 88, all over 2 times a. We're going to use a calculator on this one. Okay. 25 minus 4, 25 minus 8 times negative 88. So I just said 8 because 4 times 2, but it doesn't really matter. That is a negative, and then don't forget that negative on there. So you got 729. Now you could leave it like that, but you'd be wrong because you need to go ahead and check. First thing you do is just go, I knew 80 wasn't a perfect square because 81 is. 729, second square root of 729, go up and grab it, and it is 27. So technically this is 5 plus and minus 27 over 4. That's not a good enough answer though. I need to know the two. 5 plus 27 divided by 4, and 5 minus 27 divided by 4. 5 plus 27 is 32, and 32 divided by 4 is 8, so one of my answers is 8. 5 minus 27 is a negative 22. That simplifies both by 2, so it is a negative 11 halves. Okay. 49. K equals opposite b. Opposite b is positive 4 plus and minus the square root of b squared, which is positive 16 minus 4 times a, which is 6, times c, which is negative 5, all over 2 times a. Okay. Actually, 4 times 5 is 20, and 20 times 6 is 120, so it's 136 in there. To be careful, I'm going to check. 16 minus 4 times 6 times negative 5. Okay. Alright. 136 is not a perfect square, but I have a feeling it does divide by something. So let's just start dividing by perfect squares. Divided by 4 goes into it 34 times. 34 divided by 2 is 17, so that means 136 can be written as 4 times 2 times 17. That's prime, that's the only perfect square, so we're good. Okay, So 2 times 17 is 34, so this is 4 plus or minus the square root of 4 times 34 all over 12. Square root of 4 is 2, so 2 goes on the outside. 4 plus or minus 2 square roots of 34 all over 12. Now we can simplify the 4, 2, and the 12. They all divide by 2. So 2, 1, 6. 2 plus or minus the square root of 34 over 6. And there you go. Okay, on 50, I was going to say 20. On 50, it is a quadratic. It's not in quadratic, well, it is in quadratic form. It's just not in standard form. I need to get everything on the same side. I want to keep the quadratic positive, so I'm going to go ahead and add 8p and subtract 7. So we've got 2p squared plus 8p minus 7 equals 0. Okay? So p equals opposite b, negative 8 plus and minus the square root of b squared. 8 squared is 64 minus 4 times a times c all over 2 times a. 4 times 2 is 8, and 8 times 7 is 56. That is a negative times a negative, so it's in actuality plus 56. That should be 120. Yeah. So negative 8 plus and minus the square root of 120 over 4. I know 120 divides by 4 30 times. And 30 is just 2 times 15. So yeah, I think it's 4 times 30. I'm just showing you. This is a perfect square, okay? If between 2, 3, and 5 I had another 2 numbers that were the same, then I could say there's a bigger perfect square. Like if there had been another 2, then it would have been 4. Another 4, so 16 would have gone into it. I don't know if that makes sense to you or not. As it is, if it doesn't, then just start dividing by the perfect squares. 4, 9, 16, 25, 36. It's actually better to start from the high numbers, but I just work from the low, and then I think about the prime factors. So I know it's negative 8 plus and minus the square root of 4 times 30 over 4. Remember, you cannot divide these by 4. This is not inside this is inside a square root, and that's not. And you can't divide those unless you divide the number in front of the square root as well. Square root of 4 is 2. So I've got negative 8 plus and minus 2 root 30 over 4. They each divide by 2. The numbers in the front. So I've got 4, 1, and 2. Negative 4 plus and minus the square root of 30. I don't need that 1. All over 2. Okay. And the reason why I can divide this by 2 and not that is for the same reason that you can say 2x divided by 2 is just x. 2 times x divided by 2. You still just divide the 2's. Move the x in. Okay. We need to get everything in order. I'm going to leave 6b squared over here. I'm going to subtract 11b and subtract 1 so that it's in standard form. Okay. So opposite of the middle term, so positive 11 plus and minus the square root of b squared, which is negative 11 squared, so 121, minus 4 times a, which is 6, times c, which is negative 1, all over 2 times a. 4 times 6 is 24, times 1 is 24, but it's a negative times a negative, which is a positive 24. So 121 plus 124 is 145. Yes. 11 plus or minus the square root of 145 divided by 12. Let's see if 145 divides by anything. I should check, make sure I'm right as well. 121. Yeah, okay. 145 divided by 4. Nope. 145 divided by 9. It's kind of my only hope, but it's not. What is 145? 145 divided by 5 is 29. Okay, so 145 is 5 times 29. 5 is prime, 29 is prime, so there's no perfect square that divides into it. So we're done. Okay. On 52, I need to get all the terms on the same side. So I'm going to subtract 2x over here. So that means that's a negative 5x. So x squared minus 5x minus 6 equals 0. It does say to solve the quadratic formula. I have a feeling I could factor this one though. So let's just do that real quick. What are the factors of negative 6 that add up to negative 5? Again, and 6 and negative 1. If you do 2 and 3, if you do negative 2, negative 3, that would add up to a positive 6, so that wouldn't work. But positive 6 and negative 1 multiplies to give me negative 6 and adds up to give me, oh, just kidding, negative 6, positive 1. I need to get negative 5, so x minus 6, x plus 1 equals 0, and x equals 6, because 6 minus 6 equals 0, and negative 1 is negative 1 plus 1 equals 0. So I'm thinking those are my answers. Let's check. X equals opposite b, so positive 5, plus or minus square root of b squared. Negative 5 squared is 25, minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 1. 25, and then that's a negative times a negative is positive. 24, 25 plus 24 is 7. Sorry, 49, which is 7, which take the square root. 5 plus 7 is 12, divided by 2 is 6. 5 minus 7 is negative 2, divided by 2, which is negative 1. So I'll try. Now, if you can factor it, can you go ahead and do that? Yes, but if they say using the quadratic formula, am I going to expect to see the quadratic formula? Absolutely. Okay, the last page is graphing inequalities. So determine the region bounded by the following inequalities. And I said bounded. In some ways they have boundaries, but in some ways it might just go on infinitely. So what you kind of have to remember is how to graph and how to graph inequalities. So just a little side note. If you're graphing like y is greater than x plus 3, right? So that's a y-intercept of 3 and a slope of 1. So up 1 over 1, up 1 over 1. But it says greater than, so what you would do instead of a solid line is that you would do a dotted line, because you're not including the line. And it says greater than, so you would shade above it, right? If it had said greater than or equal to, then you would have done a solid line. And if it would have said less than, then you would shade it below. Okay? Yeah. So this first one says y is greater than the absolute value of x. So the absolute value of x is the function where, if you take the absolute value of a number, it makes it keeps it positive, or it makes it positive. So the absolute value of 0 is still 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. So that's just exactly that. But on the left-hand side, the absolute value of negative 1 is 1. Negative 2 is positive 2. So you might remember the v function. So we're going to go ahead and do this. And since it just says greater than, it doesn't say greater than or equal to, I'm going to connect with a dotted line. And it says greater than, so I'm going to draw arrows going up so that when I do shade, I know I should shade above the line. Okay? For the next one, I'm going to do y is less than or equal to 1/3 x plus 3. So the y-intercept is positive 3. 1, 2, 3. And my slope is 1/3, so up 1 over 3. 1, 2, 3. I don't care if these functions made it perfect. It doesn't matter. Up 1 over 3, 1, 2, 3. Down 1 to the left 3, 1, 2, 3. Now, in a situation like this, I do expect your graph to span the whole width of the grid. Okay, down 1 over 3. Okay, so it's less than or equal to, so it is a solid line. And then it says less than, so we draw an arrow going below. So what you need to figure out is the only region that is above the absolute value but below the linear function, and that would be only this region right here. And so that would be your shaded region. Okay? Alright, let's go to number 54. Now the absolute value of y is less than the absolute value of x plus 2. So all this is the absolute value function, the v, shifted to the left 2 because it's plus 2 on the inside. And just so you can see, The v here happens at 0, but the v here, if I plug in -2 plus 2 is 0, and that's where I get that. If you plug in -1, you get -1 plus 2 is 1, the absolute value of 1 is 1. So it's basically the v function shifted to the left too. And by basically, I mean it is. It does say less than, so I'm going to do a dotted line because it didn't say equal to. And it says less than, so I'm going to draw arrows going down. So I know I need to shade below that one. Okay? Oh my goodness. I completely forgot the -3. My bad. Okay. Just kidding, it's the left 2 and down 3. 1, 2, 3. So we're going to forget the one I drew above it. And it needs to be below this right here. I don't suggest you doing this, but I know that I'm not going to need that area, so I'm just going to, okay. Alright. Now, this right here says y is less than -1. Y is less than -1. So, all that's telling me is that all the y values have to be less than the y value of -1. So if x equaled, I don't know if you remember the first page, but x equals 2 is a vertical line through 2. If it's y equals 2, then it's a horizontal line through y equals 2. Okay, so when it says y has to be less than -1, that means I'm going to go to -1 on the or on the y-axis. It says dotted line because it says just less than, and I'm going to draw arrows going down. So it needs to be below both of these functions. Okay, so I would say this region is below all of this, but getting to this, though this in here is less than the horizontal, it's not less than the absolute value, so you have to account for that and do this right here. And so your region is actually only that. Okay? Alright, on 55, we have the quadratic -x² plus 4. So that is a parabola shifted up 4 and facing downwards because of the negative. If you're uncomfortable with that, you can think of it as -x minus 0 squared plus 4. So the vertex is at +0, +4. And then there's a 1 on the front, so we go to the right and left and go down 1. Let's plug in 2. So if I plug in 2 for this equation, I've got 2 squared, which is 4. I've got -4 plus 4, which is 0. So 0 on either side. Now I'm going to go ahead and I'm going to keep going because I want to span kind of the graph. I'm going to plug in 3. 3 squared is 9. -9 plus 4 is -5. And that's going to be the last one I'm going to be able to see. It does say greater than or equal to, so I know it's a solid line. We're including the parabola. And it says greater than, so I'm going to draw arrows going up. So I know wherever I shade is going to be above. Okay. The other function is y is less than 6. So very similar to the other problem. Oh, did I really leave those all the same? I'm going to change 56. Oh well. Okay, y is less than 6 means a horizontal dotted line at 6, and it says less than. So less than. I'll have it changed before you get it, so you'll just see that it's changed. So this right here is less than that, but it's got to be greater than that, so it kind of is the area in between the two functions. And it would just keep on going along with the parabola. So there you go. Okay, over here. I'm going to graph the parabola and then I'm going to change that. Okay, so this has a vertex at, and see it's +2 on the inside, so we're going to go left 2 and down 3. So left 2, down 3. There's a positive 1 on the front, which means I'm going to go to the right one and to the right and left 1, and I'm going to go up 1. Now, you might, well, if you do this often enough, you know it's a pattern, but I'll just go ahead and plug them in. Okay. If I plug in 0, 0 plus 2 squared is 2. Sorry, 0 plus 2 is 2, and 2 squared is 4, and 4 minus 3 is 1. So now here I'm at 1. And here I'm at 1. And you might have noticed that if it's 1 the first time, the next one is 4 up as opposed to just 1 up. But anyway, whatever. Okay. And the next one's going to be 9 up. If I plug in 1, I got 1 plus 3. 1 plus 2, which is 3. 3 squared is 9, and 9 minus 3 is 6. So at 1 I'm at 6, which is 9 up from negative 3. 1, 4, 9, the perfect squares. That is a pattern. Oh, yeah, okay. It says greater than, so it is a solid line or solid curve. And it says greater than, so I'm going to draw arrows going up. Okay. And I'm going to do y is greater than or equal to let's go with 2/3 x minus 4. Okay, so 2/3 x minus 4 is a linear function. You've got negative 4, which is the y-intercept, and then slope of 2/3, so up 2 over 3, 1, 2 over 3, 1, 2 over 3, down 2 over 3. This is greater than or equal to, so this is a solid line. And it says greater than. So remember, they both have to be satisfied. Okay? So if I think about shading over here, I can't, because it's got to be above the parabola, and the parabola, that would be below the parabola. This right here, between these two functions is above one but not above the other. So technically, the only place that these are both greater than, or the only region that is greater than both, is inside the parabola. So there you go, that's the only solution. Okay, that is the end of the entrance packet. We will probably be coming up with a couple more examples as we do the quizzes, but that is what you need to know, okay?